let's go. We have 45 minutes, and I am sure that we're going to take the whole thing. And the topic for today, for my session, is how to make a world-class integration testing library. So when I thought about what I want to share here, is I thought about obviously, I work on Testcontainers, which is the collection of libraries that simplify integration testing and I'm going to talk a little bit more what it does, but not just from the technical point of view, what it does, but from the qualities and what we did when we developed it, or how it developed through the years, what made it possible to become one of the most popular libraries, and how it stands out from the developer experience point of view. And I thought that would be very interesting to share. So this is, as they say, the views are my own. So this is don't judge me very hard, the Testcontainers maintainers, if I say something. Yeah, excellent. Right. So Testcontainers. Testcontainers is pretty great. It's a collection of libraries that integrate on one end with Docker and allow you to run anything that runs in a Docker container in your integration tests. This is an incredible functionality that people use all the time. And it started more than 7 years ago with the Java version of the Testcontainers project. And by now it grew into a larger community and a larger ecosystem, both in terms of technologies that are supported out of the box or maintained with proper abstractions, but also in different programming language ecosystems. So we have the same approach and the same library in Go. We have the version for Node.js, we have the version for Python, for Rust, for .NET, and so on. So the approach that Testcontainers embodies was so interesting to developers and so popular that people just created the versions in their favorite languages. And even now, I think the Java version remains the most popular. And my background is in Java, so I'm going to show a little bit of examples based on the Testcontainers Java, but just know that there are other languages. And people very often are surprised they move from Java, say, to Go, and they're like, oh my God, I found that Testcontainers has the version for Go. This is a lifesaver, and they're very, very happy. And that makes us very happy as well. So before I start talking about what makes Testcontainers so special and how the developer experience of Testcontainers kind of shapes to be, I want to show you a small example. So we are all on the same page, what Testcontainers does and how it helps you. My name is Oleg Šelajev, and I work at a company called AtomicJar, which is a startup by the maintainers of the Testcontainers Java library. And you can find me online. And yeah, we're going to chat here with any questions, or just send me a DM, and we're going to talk later. I'm going to show you an example of an application. I'm going to run some integration tests. And it doesn't matter what the application is, but it talks about the sessions at the conference and the ratings for the sessions. The important bit is here on the right. It has 3 service dependencies. It depends on the database to store some data, on the Kafka to talk between the components of the same application, because why not? And Redis to store some additional data. So those service dependencies need to be present when we want to run this application or when we want to test this application. So normally it would be kind of like hard to figure it out and run, but with Testcontainers, I can do the following thing. So this is my application. It's a typical Spring application in a Java world that would be very familiar to all of you. So I have a bunch of tests that I have here. They're normal unit tests that any Java developer would recognize, and they depend on the components of the application. For example, the talks repository, and one of the tests here checks whether the talk by a given ID exists. And the other tests are a little bit more high level. So we check the health endpoint, and we actually use the application by sending HTTP requests to it, and so on. So normally, if I would just run those tests without any Testcontainer support, my test will fail because the database is not there, the Kafka is not there, my Redis is not there, so the application cannot work. And I would need to manually set up the environment for the integration test, which is error prone. People forget it. It doesn't work the same way in CI, where there is a different operating system. It very quickly becomes a mess. So what I can do with Testcontainers is very simple. I can import the dependencies, and I have a bunch of them here for test containers, Kafka support, for test containers, Postgres database support, integration with JUnit, and so on. So I just bring in the libraries, and then in my application test, what I can do, or here I would do that in a superclass, I can just, in the API, using my IDE, using the programming language that I know and use daily, I can just declare those service dependencies. For example, I can say, I would like a generic container that runs the Redis 6 Alpine Docker image and exposing the ports so I can actually talk to the Redis through network. Or I would like a Kafka container, which is even a larger abstraction on top of the test containers API. Or I can just say that I would like the database and use it as special magic URL support. We're going to talk about that later, but I can very easily, using my normal Java API, or in the JVM world, that would be any other, like Kotlin API or Groovy or whatever language I want to use, or similar abstractions for the other libraries. For example, in test containers node, there will be a similar generic container abstraction in JavaScript. I can request those, I can run them, and then I can set up my application and the test will run. So if I just run my test here, it will think for a moment, but let's see what the output here is. This is the important bit now. So the API there is just the preface to the session, but here starts some interesting things. So test containers connects to Docker, and it finds what Docker version there is. It does a few checks that the Docker environment is actually healthy and we can run with it. And then it runs the test against that environment. So you can see, for example, in the logs, it creates a container for Kafka, it creates a container for Redis. You get the point. Very easily, I can create the dependencies, service dependencies that I need and run them in Docker containers. And my tests will run against the actual technologies I will use in production. And I can do either off-the-shelf software like databases, message brokers, Elasticsearch, HashiCorp Vault, cloud technologies like AWS via the local stack, or we have a G Cloud module for Google Cloud Technologies, and so on. I can run those, or I can run the mock server to mock the third-party API that either I control myself or somebody else controls on my team, or in the company another team controls. And then they can verify the correctness of those using the contract testing. But that's the whole separate topic for this, maybe not even a single session. But in a nutshell, test containers manages my service dependencies, integrates both with Docker and with my application frameworks or my testing frameworks like JUnit, and allows me to manage my dependencies with the API, which is very, very convenient, right? And this is just the example that I wanted to show to set up the baseline. What are we going to talk about? We're going to talk about this integration testing libraries and how it happened that this integration testing library is one of the most popular. We're getting more and more growth, more and more people start download it and run it and use it. And not just the amount of builds that they like test containers is being run in, but also the amount of unique people or unique IPs that download test containers dependencies. So clearly this is not just the cloud CIs running builds again and again and again, because those have the limited IP ranges. So if unique IPs are growing, that means people all over the world are using it more and more. So how did it happen? How did it happen? I'm going to use, here is the disclaimer. I'm going to use we when I talk about the test containers, but actually this is, I joined the team fairly recently, a few months ago, and started working with test containers all the time. And some of the decisions, or most of the decisions, were implemented before that. So when I say we, it's actually the brilliant engineers that created that, and I'm just using it colloquially, so to speak. Right, but I think we did a very good job. But besides us doing a very good job, I think a few things had to fall into place. When you want to build a very popular open source project, you don't start with the popularity. You don't aim to be the most popular open source project for any particular problem. You just want to solve the problem that actually is widespread so people know about that, but also that the problem that is a reasonable problem. It needs to exist, the need needs to be there, and then your code needs to be fairly excellent, your solution needs to be good. That's how you build the popular product. Duh. So in the test containers case, one of the necessary components for the success, I think, was the migration from the older architectures and older understanding how we build software and how we test software. So a few years back, several years back now, when the computers were still fairly large and the phones had buttons and Instagram was young, and I don't know, maybe newer startups didn't exist yet, we all thought as the industry, we had ideas about how we test our applications and which types of tests do we use. And we used mostly unit tests, which were the base of our coverage for almost all projects. They would be small, they would test isolated components, they would test one component of the system at a time, and there will be many of those. And then we'll have smaller amount of integration tests because they were harder to maintain, and then they were slower, and they were inconvenient, and they were flaky and broke often. So there were fewer of those because you couldn't rely on them confidently to release with confidence. And then there would be end-to-end tests that test in the production-like environment, and there were even fewer of those because they were even flakier, slower, and harder to maintain. Now the change to microservices architecture happened, and then people started to realize that having too many unit tests doesn't make much sense when your application is split into like a myriad of microservices. So people started changing their approaches to testing, and figured out, many teams figured out, and here it is the link to the Spotify engineering team blog, where they describe how they moved from that system with the pyramid of tests to a honeycomb, where the base of their tests, the most important and most frequent and most popular type of test would be the integration test. And then there was a smaller amount of tests that test implementation details or test the fully integrated solution in a production-like environment. And the reason for that is very simple. If your microservice does a little bit of computation itself, but depends on 3 external systems that it needs to work properly, it doesn't make sense to test it with unit tests. You want to test the integration pass, that it works properly with the database, that the connection to Kafka is established correctly, and the communication via Kafka works. And integration tests just make sense. And also test containers Java, for example, existed already back then. So I would say that it was easier to create proper integration tests. And now you can just rely on them. You can rely and make your testing suite mostly integration tests, because they will touch the code path that you would use in the implementation details anyhow, and you will verify those behaviors, and you can verify more behaviors using more complex integration tests. And thanks to proper approaches, for example, using test containers, it's even as easy to maintain and run as unit tests. So that shift happened, and the need was much larger and is now than before. And that was one of the factors that contributed to success, is because the problem became much more widespread. The second thing why test containers became so popular is because it was built, and we're standing on the shoulders of whales, by which I of course mean Docker. Docker became, well, so widespread that it's found on almost any developer machine. All CI services support it to a certain extent. There are some maybe niche use cases where it's a little bit awkward to use, specifically if you use Docker and Docker setups. But on developer workstations, it's almost universally present. So making test containers work with any compatible Docker environment was a great choice, because that meant that the prerequisite for running integration tests with test containers are already present on the developer's machine. So they don't need to install any additional software much. They already have widespread and popular solution as Docker, and test containers just can build upon that and improve the developer experience of using integration tests. And well, there is what to be improved. So Docker embodies and solves two big problems. One of them is how we give other people our software to run. So we package it in Docker images and we send the images to people and they run it. And also the alternative, the duality of the dual of this is also true. This is how we run other people's software. We don't install applications, or we don't always want to install applications, but we just want to run them. If our integration tests depend on Kafka, we don't want to install Kafka, or we don't want to install Redis, because there will be the conflict of the necessary versions when we run multiple projects. It will pollute our global namespaces in the workstation. We just want them nicely packaged, isolated, running in the Docker and be present. So, and Test Containers uses that we can run any software in the Docker and makes it available for your integration test nicely and conveniently. But the question is just running software in a Docker container the goal of Test Containers? And I would argue that it's not. It is the means to an end. Because if the goal is to allow people to run software in Docker, then we would probably get much different versions of Test Containers, or even just run with default Docker provided API and capabilities. Often, if you constrain yourself to just solving the particular technical task that you might think is the functional tools, and remember, we're talking here about developer tools, you will get a solution that is a little bit joyless to use. It might not use reliably, or it might be not the best. Because if you just constrain yourself by solving the technical problem, and you don't concern about the user experience side of things, how people feel when they run your software, or when they run your libraries, or when they use your product, then you probably will not get the best version of what you can produce. So I think Test Containers team did consider the developer experience a very important part of the functionality they support. And I would argue that the existing capabilities that Docker provides are a little bit awkward, specifically for the integration test use cases. Right? You can run all the services that they run using the API. You can run them using Docker Compose, YAML, but do you want to do that? Probably not. Probably you don't want that. There are a number of problems here. It's not flexible enough for multiple tests. It's hard to run the service in a different way for different test cases that you have. It's hard in case of databases, for example. It's very inconvenient to populate this database with new data for every particular test case, and it's just not the best. So the question is then, what is the problem that we're solving? What we are trying to achieve with Test Containers, and what functionality it needs to have beyond just integrating with Docker to be a great solution? So, and the answer to that, I think, is that we would like ordinary developers who have their skills, who have their obstacles on solving the problems that they have and the tasks that they have. We want them to use those skills and move away the obstacles as much as possible. We would like specifically to simplify how they run integration tests, not just allow them to run them somehow. And remember, so we want them to make how do you say that? We want developers to be the happy superheroes of their problem solving. And you do that not by providing any kind of solution. Remember that if a hard problem is replaced by a hard solution, that is not what success is in general, in developer experience specifically. And also, it's not when you are replacing an easy problem with an equally easy solution. That's no improvement either. You always want to have your product or your library or your tool to lower the complexity of solving problems. So you want to make easy problems trivial or absolutely, well, seamless to solve, and you want to make hard problems easy to solve. And if you can get even more and try to tackle problems that you didn't envision in resolving, but you have some ideas how to solve that, and you can empower developers to do that using your tooling, then that is what success looks like. Reducing the complexity of the solutions. Right. So this is one, and this is what the Java API or the language-specific API in test containers does. Any developer using their language know how to use their language. They have the tooling to use their language. They have the tools to explore the library and what it does. And having any Docker container, any Docker image at their fingertips using the API that they're familiar with, I think this is a very big complexity reducer for many people and teams. So that's the convenience factor. The other factor is what I would call reliability, but I also think reliability is maybe not the best word here, because it often talks about the production, how in production something is reliable, that it never breaks. So it's a little bit, I would like a different spin there. So I would say trustworthiness of the project or of the tool. And remember, what you're building for the developers, what we want to have, specifically in testing or any tool, we want to have the failures manifest as early as possible. We want to have all kinds of checks and safeguards. We want to ensure that if you run something on a machine that is not properly set up, you see that, and you not just see that, but you also communicate that back to the developer, that their environment is missing something, or that you cannot perform the function that you want to do. And not just saying like, oh, an error happened, please cancel. But you try to explain in the error messages what exactly happened. And that needs a conscious effort on your part as a developer of the tool to figure out what are the possible problems can be and what are the possible solutions can be there, and try to predict those as early as possible. And then if your tool goes past the initial stages, then it's supposed to work properly. So that's the situation. The other part is you would like to limit the amount of configuration that ordinary developers are exposed to. And that means that you need to have sensible defaults parameters for all intents and purposes. You do have the configuration, you do have probably the thousands of options to configure, and we have like probably, well, maybe not thousands, but like many dozens of configuration options for test containers, and they're not all exposed in your face, and we don't make the developer to choose those, because we know that developers are people too, and specifically because we want to remove the obstacles from their way to better integration tests. We try to put the sensible defaults into the programs, and that means, for example, that when we run our tests, and test containers starts and it looks at the environment, it tries to find the Docker environment against which it's going to run the tests, and it does, for example, the system checks. And it is a minor thing, but I think it shows the approach that the library takes. It tries to be predictable, it tries to be reliable. So it knows that for its work, Docker needs to be of a certain version, and the Docker environment should have some space, disk space, and that it needs to be able to pull the images from the Docker registry, and it needs to be run those images and send the network's request to those, and the containers should be accessible. And it runs those checks before even it starts doing anything with the containers that the actual end user requested, as just the sanity checks. And very often that leads to the situations where if the environment is not ready to run test container-based tests, then the sanity checks fail and the system doesn't proceed, which is very great, because the developers then can focus on one problem at a time and not just figure out, oh, what went wrong, why are my tests not working, why are they one day red and one day green, and that is the worst. That is the worst. Right. Besides the system checks, what else Testcontainers does? What I feel is very interesting from the user experience point of view. Test specifically what you want as a developer to test to be. You want them to be reliable, and reliable means that you can run them again and again in the same environment, and it will produce the same result. So during the test, Testcontainers will spin up a number of Docker containers, and what it does, very importantly, after the test, it cleans those up, and it doesn't just clean those up in case the tests pass successfully, but it cleans them up and removes the running images and stops them and removes the intermediate Docker images that were created during the test runs. It does that automatically in all cases, whether your project tests fail with errors, or whether they crash, or whether your JVM process crashes. It uses the Docker-based, you can see Testcontainers RUC Docker container as the means to clean up after everything else fails. And this is a very, very important feature, is that it leaves the environment where it runs tests in the same way as they were before the test, which is great, because then you can run your test again and again and again. Your workstation will never run out of memory or HDD space for your Docker volumes, and you just run them. More importantly, you can run your test the same way in your environment, on your workstation, or on your colleague's laptop, or in CI, which is a particularly important point. You want to run tests the same way everywhere. And the cleanup and the Docker checks serve that purpose, increasing the trustworthiness and making the test more reliable. And on top of that, Testcontainers library tries to go an extra mile for the particular integration test use cases. For example, there are very often when you run software, you get port conflicts. If you want to expose a database port from a container running on your machine, and you expose the same port as you would often do in the XML or YAML configurations, you'll get port conflicts. You cannot run two versions of Kafka using the 1992 port for the brokers. So Testcontainers goes an extra mile, and it randomizes the ports where you map on your host machine, and it does it consciously. And it's a little bit unintuitive initially if you don't think about that, because if you're just if you want a library that does exactly the same thing as you would do from the command line, doing docker run publish port 8080 to 8080, then that might be unintuitive. But if you think about that for a minute, then it makes a whole load of sense. And then after you think about it for a minute, you will never want to go back. So port randomization is something that Testcontainers consciously decided to do, and they do. They avoid the hard-coded data scenarios and provide an easy API to generate data for the databases. There are a number of ways how you can send the data into your database running in a Docker container. Some of them are the Testcontainers-based API. We're going to see that an example a bit later. But Testcontainers embraces the data-driven test, because we know that the tests will use different data. The tests will use also often incomplete or corrupt data, because you need to test the negative use cases as well. So Testcontainers goes that extra mile. Testcontainers embraces parallelization, because if you have many tests, you might want to run your tests in parallel. And we try to always keep in mind that there are people and setups where people run tests in parallel, and we do not add features that would kind of sort of break that parallelization easily. Yeah, so just all in all, trying to go this extra mile and make sure that the approach that Testcontainers takes as a framework in general serves the purpose of having better integration tests and happier developers maintaining simpler integration tests. And that approach, that shows it's not just, me raving about how excellent Testcontainers is. For example, a recent technology rater by ThoughtWorks put Testcontainers in the adopt category, which is very, very great, because that's a strong signal to people that, you should maybe look into adopting the framework. But what what was very interesting for me is the words that they put on the page describing test containers. And they said the following thing, that it could be useful default option for creating reliable environments for running tests, right? And they found that the library of those programmable, lightweight, disposable containers makes their tests more reliable. This reliability, again, a very important, it's very important for the test use cases. You want your tests to be reliable because you want to use them as the basis to do the releases and ship your software to the users. But I think it's in general, reliability should be a priority for any tool or any project that cares about developer experience. And very often, reliability would mean trustworthiness, which is great. Right. So besides the trustworthiness stuff, last year at DevOpsConf, there was a presentation by Ellen Chiza about how DevOps is not great because we just maybe sometimes don't want it to. And she talked about, it's a very interesting and fairly short presentation. So if you have a 20-minute break somewhere, I would recommend you to go and watch that. But she showed the following page there, and she talked about how the ideal developer experience of a product is this flow channel between the complexity of the problems that people have and try to solve, and the skills and familiarity with the tools that you're offering to people. So on the vertical axis, you have the complexity of the challenges. And for test containers, that would be how complex are the systems that you're trying to model using integration tests. And on the horizontal axis, you would have how much skill you need to have to resolve those using test containers. And her point was that essentially what you want to have this channel where this necessity of the skills raises with the complexity of the problems, which makes sense. For simple problems, you want simple solutions. So, and I think Test Containers offers a very nice balance of the approaches that we recommend to different setups that I want to show you here, specifically with this diagram in mind. So let's talk about databases. A database is a very common container that people need to run. Many applications require databases, and there is a very simple way to use test containers with the database. And the simplest of those is to use the JDBC driver and use the magic URL. So when you have your configuration, normally you would just, I have an example of a Spring application because I took that from that example, but you configure your application where the database will be, and it will based on the URL, find the driver, load the driver, and establish the connection. So here's the trick. You add TC into that JDBC URL, and then the system will load the test containers driver, and the test containers driver will create the container with your database on the fly for you and configure your application to talk to that. So you just say that I want a Postgres database, and you get it. The simplest way is to just change one configuration property, have one dependency. You don't need to change the code, and voila, you have the application integration test running against the actual Postgres version or whatever database version that you have. You want to initialize the schema in there, you can do that. There are a couple of versions how you can do this. You can either initialize it with a script and point to your schema files and data files, or you can point to a certain code with the class and method name that you want to run to initialize the schema. And you can see it's a little bit more complex because you need to know a little bit about test containers, but it doesn't change the approach. You just configure your application literally with the configuration string to use that and run against the database. And you can do even more with the additional config there. There are a number of properties that you can do. For example, attach the temporary file system in memory, so you test a little bit faster and so on. But the simplest approach is just to configure your application to use test containers. You don't even need to use any API. Now, the step above that is the ecosystem of modules that test containers provides. And there are a bunch of those. You have a Kafka container, And you can, if you want Kafka, you just say, I want Kafka, give me Kafka. This is the version of Kafka that I want to run. Test containers will figure it out, pull the image, do the Docker checks, run your Kafka container, and create that. And this creates a really great user experience. You can have other modules. For example, you can have a Toxi proxy container if you want to deal with introduced network artifacts there. You can have Postgres container. You can have Kubernetes cluster container. You can run Kubernetes in a Docker container using test containers, which is mind-blowing. So if you, I don't know, write Kubernetes operators and you want to test them, using test containers is probably one of the easiest ways that you can do that from your code in a repeatable fashion. And the ecosystem of modules is actually pretty big. If you go to testcontainers.org, there are modules for almost all popular databases, cloud technologies, message brokers, IoT message brokers, and so on. WebDriver containers. There are quite a bit of modules. And why those modules are very important is because on one end, they have the test containers kind of stamp of approval. They're contributed either by the community or by the vendors themselves or by people who actually understand something about the technology in question, but they actually consist, all the modules have two things in common. So they have the developer experience and the community and the technical excellence in running integration tests from the test containers. And then on the other side, they bring the information about the technology in question. Do you know how to run Kafka in Docker? Neither did I 6 months ago, but I knew back then, and I know now that I can just say Kafka container, and somebody who knows how to run Kafka in a Docker has written that module, and the team supports that and maintains that abstraction for me. So I can just say, please give me Kafka, and my application can run in that environment without actually me as an end user thinking about how do I need to configure Kafka in a Docker so it runs properly. And this is an excellent point for both the test containers community or in general the larger, say, Java community for test containers Java, and the vendors of technologies, because very often this is the best way to test application against a particular technology, and it just makes sense. Very often you don't want to maintain like in-memory versions of your software for the test purposes, and test containers provides an excellent trade-off there, because, well, yeah, modules. And then the third step after we have the modules, there's the generic API. We saw that an example of running the Docker Redis container with a little bit of configuration based the exposed ports. But what the generic API gives you, it gives you the amazing opportunity to do anything that you would do with the normal Docker configuration, but with an API. You can specify which commands you want to run the particular Docker images. You can specify what environment variables, you can copy files into the Docker containers. For example, if you want the particular configuration for this integration test, and you have the full control of the life cycle. You can literally call start and stop on that Redis instance, and it will start and stop the containers, and you don't even have to worry about cleanup, which is the best. I know some people and some projects use test containers to spin up the instances of the database to run against during their build process to generate some Java classes based on the schema that is in the database that is populated by the liquid-based schema changes, which is mind-blowing, but it's very cool. And also, they don't care about the cleanup because the cleanup happens automatically, which is great. But what's great here is that the whole configuration, anything that you can do with that container is there at your fingertips in your IDE. So there are just different ways how you can do that. And you can have this complexity and what it allows you to do, test containers allows you to do with your setup, it grows with your challenges. So if you want more complex topologies, you can have it with the complex abstractions. If you want very simple solution to sneak in proper integration testing in your project, you don't even need to configure any code. You just, well, write the configuration for the database, and that's it. So yeah, the problem, of course, with the generic API here is that if there are no module, then very often people think that technology doesn't run with test containers, which is a little bit of a shame, but there's nothing to do. If it's not in the documentation that you can, how particularly you run Redis, then it doesn't exist. But also the opposite of that, which is the documentation. We try to keep the documentation as good as we have, but there is this assumption, at least early in the days, I know early in the days was the assumption that actually problems with documentation is that very often people don't read external docs. And even more, people very rarely read the docs that you show them in your face. Well, they will read what you show them in their face, if it's errors or the information tooltips, but they will not seek additional information on their own very often. So, which is great, because for test containers, at least for the modules that exist, all the configuration, everything that you can do with those is embedded in your IDE, because you have the DSL to do anything you want to do with the, for example, with the database, you can get the information about database names, database name, the JDBC URLs, passwords, and so on, both for setting the configuration and getting it. For Kafka, for example, you need to get the Bootstrap server's URL, and people who created that Kafka container abstraction knew that you will need the Bootstrap server's URL. So they created a convenience method for that. So as an end developer, you don't have to know that. You can just type dot in your IDE, and the IDE will suggest you, here's how you do that. So test containers removes that worrying about configuring services out of the picture, moving the obstacles away, making developers a little bit happier superheroes. And beside the end user developers, there is also why test containers is shaping to be so popular, I think, is because it also gives the capacity for the platform engineering teams to shape how the whole departments or the whole companies do the tests. So this notion that not just the end user is not just developer writing tests is the end user of test containers, but also the platform team that cares about how many of those end developers will write the tests. And test containers provides like not a meta API, but additional configuration options and abstractions that you can introduce into your code base that you can share with multiple teams there. For example, very often, individual developers might not care very much where from their Docker images come, but very often companies need to use access to private registries, and test containers provides a number of options how to configure that, which also kind of sort of the similar picture is shapes in different kind of sort of questions. And I have just 40 seconds, so I'm going to run through that. So there is a local API that you can discover typing dot on the particular objects and classes there. There are configuration options, and there are programmatic API for like the utmost flexibility that you can use. And you can use private registries. You can do a little bit of chaos engineering with toxic proxy containers, for example. So you can create different topologies and then package that as an abstraction for your team. And then you can just introduce, for example, latency. What will happen if your database doesn't respond very quickly? Will the application live or not? So you can do a little bit of chaos engineering there. You can use the reusable containers and extend the life cycle of your application through this. And there are more things. And people love test containers, not because of the simplicity, like they come for the simplicity of doing their first integration test, but they stay for the how generic, flexible, and coherent the approach is in general. So besides that, I don't have time for this, but test containers starts to shaping the local development as well, where some frameworks start running the test containers-based containers in development mode as well. For example, notably Quarkus with dev services. So you just clone your application, you run your application, and you don't need the database or anything. It will spin up one using test containers from your project, making you a happier superhero because all you need is just clone and run. Right. All in all, I think 20 years back, we figured out that people don't write tests because it's hard to do. And there was a vicious cycle of writing fewer tests and struggling with that. And then we just needed some outside influence in the form of a simple testing framework that was available to everyone, and that made a big difference. So I hope with test containers, we are on the similar path to simplify and make more popular integration tests for all. So thank you very much. This is the session about test containers and why I think test containers has excellent developer experience. And my name is Oleg Šelajev, and you are watching DevXCon. Thank you.
Hi! Oh, that was such a great talk. Thank you so much. We actually had a few questions, but I think some other folks from AtomicJar answered them on our Discord channel, so I won't bring it up here. I just wanted to ask one question from me. So if people want to help out and get involved, do they just head over to the repo and contribute as people usually do through open source?
Yeah, all the frameworks there are open source. So AtomicJar builds a product, which is the cloud backend for running your test containers tests. But the frameworks are all pick the one that you want in your favorite programming language. Go start the repository, subscribe to some issues, try to find something, start using those, and then contribute. Yeah, I think we would love any help, and yeah, that'd be great. Yeah, just go to GitHub, and alternatively, we also have the Slack channel that you can find on testcontainers.org website. But if you don't want to chat with us and want to try the technology first, then yeah, GitHub is the way.
That's amazing. Thank you. We'll also add some links on Discord, so if anyone does want to hang out with you, then they can do. But thank you again for your time. This was an amazing talk, and I'm really excited to distribute it to everyone else. Thank you again for joining.
Thank you for inviting me.